This comes out of section 1.7, infinite series. Here I want to talk about the idea of divergent or convergent, and it is specifically related to these series. If something has a convergent sum, it means we can find the answer. It has a real number answer that we can find. Like the previous example, we found an answer of 120. So, in simple terms, has a sum that we can find. Divergent means you can't find the sum. There's no way of saying what the sum of cannot find. So an example would be, let's do a couple of these where we're just asking divergent or convergent. What if we had 1 plus 1 plus 1 plus 1 plus ... Well, if you looked at the sums, the sum of the first term is 1, and then 2, and 3, 4, 5, 6, it just goes infinitely large. You can't say what this is approaching. It's not approaching anything. It just gets as large as you want it to get. So definitely divergent. This thing has a divergent sum, or in other words, you can't find the sum. Even something like this, if I have 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus ... This thing doesn't head to infinity, so it's tempting to say, oh, it must be convergent. But if I look at the sums, if I add up the first term, S1 is 1. The sum of the first two terms is 0. The sum of the first three terms is 1. The sum of the first four terms is 0. The sum of the first 5 terms is 1, etc. It bounces back and forth, oscillates between 0 and 1, 1, 0. There's no way of saying what the infinite sum is going to equal. Is it going to equal 0? Is it going to equal 1? And so certainly we would also say that this one is divergent. Now, if we were given something like an earlier example where we had, let's say 4 plus 12 plus 36 plus ... Even in just looking at that, I can see that the sum of the first term is 4, and then 16, and then 52, and these numbers are getting larger and larger and larger. And because the common ratio of this geometric series is greater than 1, this definitely is divergent. There's no way of finding the infinite sum of this. Now, if I turned that around a little bit and just said, what's 36 plus 12 plus 4 plus ... This is a little bit different because these numbers, it's again geometric, but they're shrinking. They're getting smaller. Common ratio of a third. This one up above, the common ratio is greater than 1, divergent. In this case, the common ratio is between 0 and 1, and so it is convergent. And if it's convergent, I can actually find the infinite sum by saying, oh, it's this a over 1 minus r. So first term, 36, divided by 1 minus, now the common ratio here is a third, so I'm saying what's 36 over 2/3, or 36 times 3 over 2, and you should get an answer of 54. That no matter how many terms you added up in this particular series, you would never exceed 54, and you would just get closer and closer and closer and closer to an answer of 54. Now, just before I end this example, I wanted to talk about the idea of sigma notation. Sigma is just a fancy Greek letter, and we steal from Greek letters often when we're doing things in math and science. It looks kind of like a big crooked or a big pointy E, and I might say something like this: n equals 1 to 6 of 4 to the n. What the sigma means is add them up. And start with n equals 1 and finish when you get to n equals 6. So, in other words, 4 to the 1 plus 4 to the 2 plus 4 to the 3 plus 4 to the 4 plus 4 to the 5 plus 4 to the 6 is sigma notation expanded into an actual sum. And you'd see in this case that this is actually a geometric series. It would be 4 plus 16 plus 64, etc. You could find the answer to it. If I had sigma notation n equals, and it doesn't have to be n, let's call it m, just to make a point that doesn't need to be, and it could be m equals 5 up to 8 of 3 times 2 to the n, or something like this. We have 3 times 2 to the 5, plus 3 times 2 to the 6, plus 3 times 2 to the 7, plus 3 times 2 to the 8. So nothing we haven't seen before, because again, it just turns into another geometric series, but just a notation that was in the pure Math 30 curriculum in the last math curriculum, but they took it out of Math 30-1, so it's something we need to review at least a tiny bit because you will see it occasionally.